Today we are doing lesson 10.7, looking at MAD and comparing populations. Our I can statement for today, I can use measures of center and variation to compare populations, and I can use random samples to compare populations. So for our first key idea, we are going to talk a little bit about mean absolute deviation, which is also abbreviated MAD. So our key idea or our steps for finding the MAD, step 1 is to find the mean of the data. That's when you add them all up and divide by the number of numbers. Step 2 is to find the distance between each data value and the mean. That means to subtract your number with the mean. Step 3 is to find the sum of the distances in step 2. And then step 4, divide the sum in step 3 by the total number of data values. So you're going to find the mean, you're going to subtract, and then you find the mean of your new numbers. That's the MAD. So let's take a look at this one. You record the number of raisins in 8 scoops of cereal. Find and interpret the mean absolute deviation of the data. Mean absolute deviation tells how spread apart numbers are from each other. It gives a number value to how far numbers are away from the mean. Are they close to the mean? Are they far away? MAD is a way to tell you that. So that is what MAD is. Let's go ahead and practice finding it. So the first thing we do is we add the list of numbers together. So we're doing 1 plus 2 plus 2 plus 4 plus 4 plus 4 plus 5. All right. And so we are going to add all of those values together. When we do, we get 24. And then we count our numbers. We have 8 numbers. We divide 24 divided by 8, we get 3. That is our mean. So then the next thing that we need to do is subtract each number with the mean. So I'm going to make a new list of numbers. I think I'm going to switch color here to write it. And I'm subtracting each one with the number 3. So if I do 3 minus 1, I get 2. If I do 3 minus 2, I get 1. 3 minus 2 is 1. 3 minus 2 is 1. Here I would have to do 4 minus 3 is 1. We're finding the absolute value of the difference. So the bigger number always gets subtracted first. 4 minus 3 is 1. 4 minus 3 is 1. 5 minus 3 is 2. So then I need to find the mean of my new list of numbers. Here's my new list of numbers. I'm just going to outline it here so it stands out. So I'm going to do 2 plus 1, 3, plus 1, 4, plus 1, 5, plus 1, 6, plus 1, 7, plus 1, 8, plus 2 is 10. I still have 8 numbers. So I'm going to do 10 divided by 8. That's going to tell me my MAD, which is 1 and 25/100. All right, so it says find and interpret. So here's our answer for the MAD, 1 and 25/100. All right, so that's what the MAD is. Now we're going to interpret, which means explain. So I'm going to write the average number of raisins is 1.25 away from the mean. 3 raisins. What that tells you is the number of raisins in each scoop is pretty close to each other. That's a pretty small MAD. If it was 10, then there's a huge amount of difference in what you're getting from one scoop to a next. All right, let's take a look at this next one. Find and interpret the mean absolute deviation of the data. Go ahead and pause the video and try this one on your own. Okay, let's check our answers. So the first thing we need to do is add everything together. So 5 plus 8 plus 10 plus 13 plus 14 plus 16 plus 22, that is going to give us a total of 96. And then there are 8 numbers, 1, 2, 3, 4, 5, 6, 7, 8. So our mean, we do 96 divided by 8 and we get 12. Now we need to do the MAD. So I'm going to erase this. And I'm going to make my new list of numbers. I'm going to subtract each one with 12. So 12 minus 5 is 7. 12 minus 8 is 4. 12 minus 8 is 4. 12 minus 10 is 2. 13 minus 12, because the bigger number always goes first, is 1. 14 minus 12 equals 2. 16 minus 12 equals 4. And 22 minus 12 is 10. All right, so this is my new list of numbers that I need to find the mean for. That's right there. That's my list of numbers. Okay. So I'm going to add these guys together. 7 plus 4 plus 4 plus 2 plus 1 plus 2 plus 4 plus 10. When I add those together, I get 34. I still have 8 numbers. So when I divide, I get 4 and 25 hundredths. So I'm going to write the numbers. I don't know what these are. Are 4.25 away from the mean of 12. So on average, they are about 4 and 25 hundredths units away. Right, on average. So these numbers are definitely way more spread apart than the ones from the raisins. This mean MAD is much bigger. That tells you you have a bigger spread. All right, so now that we know about mean absolute deviation, we're going to go ahead and use it to help us compare populations. So in the problems that we're going to do coming up, they're going to ask us to look at 2 different things, measures of center and measures of variation. Measures of center include the mean, the median, and the mode. Measures of variation include the MAD, the range, and the IQR. We use the mean and the MAD when both data sets are symmetrical. Symmetrical means if we folded it in half, it would be about the same on each side. We use the median and the IQR, which is the interquartile range, when one or more data sets are skewed. Skewed means there's a lot more on one side than another. Okay, so let's go ahead and take a look at this first problem. All right, so the first thing we need to decide is if our data is symmetrical or skewed. So let's read about the situation first of all. The double dot plot shows the time that each candidate in a debate spent answering each of 15 questions. So these blue dots here represent how many seconds candidate A spent. And these red dots here represent how much time candidate B spent. So for each candidate separately, we imagine a line kind of cut through where the middle of the data is. And then we imagine what it would look like if it's folded. So I have 3 here and 3 here. That would match up exactly. I have 2 and 1, so it's not a perfect match, but it's pretty close. 2 and 2, 1 and 1. So that is very, very symmetrical. Not perfectly symmetrical, but very close. Here, this 60 is kind of in the middle. Now I'm just looking at the red dots. We have 2 and 2, 1 and 1, and then 3 and 2. So neither of these are perfectly symmetrical, but they're very close. We imagine what that looks like when it is folded in half. So this is symmetrical data. And when we are comparing with symmetrical data, the best way to compare them is to use the mean and the MAD. The mean is our measure of center, and our MAD is the measure of variation. All right, so here it says compare the populations using measures of center and variation. All right, so we need to find our measure of center, our measure of variation, and then we need to compare the two. So we're going to start with candidate A. Now, this dot plot doesn't give us numbers to find the mean. They give us dots. So we have to use those dots to get the information that we need for finding our information or our mean. All right. So this first dot represents 50. And then this is 60. We have this would be 60. This would be 60. We're comparing them down to here. This would be 70. This would be 70. These three would be 80. These three would be 90. I'm just rewriting it from down here. This one would be 100. These two would be 110. And this one would be 120. So to find the mean, we would have to add all of those numbers up. So we would add 50 plus 60 plus 60 plus 70 plus 70 plus 80 plus 80 plus 80 plus 90 plus 90 plus 90 plus 100 plus 110 plus 110 plus 120. And that is going to give us a total of 1,260. There were 15 numbers here, 15 dots. When I divide those, I get an MAD, or I'm sorry, not MAD, I get a mean of 84. Which makes sense. That would be about here in between 80 and 90. It makes sense that that would be about where our mean is, about in the middle of our numbers. Now we need to subtract and find our MAD. So this was 50 and we're subtracting with 84. So I would do 84 minus 50. This one is going to be worth 34. It's 34 units away from the mean. These are 60. So this would be like 84 minus 60. That's going to be 24. I have two of them. 24, 24. These ones are like 84 minus 70. So this would be like 14 for this dot, 14 for this dot. This one would 80, so it would be like 84 minus 80. So these would be worth 4. 90, so this one would be like 90 minus 84. It's going to be worth 6, so each of these three dots would be worth 6. This one is 100, so 100 minus 84 would be 16 for this one. This is 110 minus 84, that would be 26 for each of these dots. And then this is 120 minus 84, that would be 36. So now we're going to find the MAD of those numbers. We're going to add everything together. 34 plus 24 plus 24 plus 14 plus 14 plus 4 plus 4 plus 4 plus 6 plus 6 plus 6 plus 16 plus 26 plus 26 plus 36. That's going to give us a total of 244. We still have 15 numbers. And when we divide that out, we get 16 3/10. We're going to round, oops, that's a 3. We're going to round to the nearest whole number. That's going to be about 16. All right. Now we're going to do the same exact thing for candidate B, and then we'll compare them. So go ahead and pause the video and calculate the mean and the MAD for candidate B. So go ahead and pause, try these two. Okay, so for the mean, you have to add up 30 plus 30 plus 30 plus 40 plus 50 and so on. You should have a total of 870. When you divide by 15, because that one also has 15 numbers, we get 58. When we find the MAD, we have to take each thing and subtract it from 58. So like we would do 58 minus 30. We'd get 18 here. 28. We would have 18 here when we subtracted. We would have 8 here when we subtract. Here we would switch, 60 would go on the top, 60 minus 58 would be 2. This would be 12. This would be 22. This would be 32. So then you'd find your mean of your new numbers, 28 plus 28 plus 28 plus 18 plus 8 plus 8, and so on. When you do that, you get 236. We divide by 15. We get 15.7. It's about 16. Okay, we are not done yet. We have our measures of center. We have our measures of variation. We need to compare them. So when I compare them, here from the mean, compare in math means which one is bigger or are they the same. So for the mean, candidate A has a bigger mean. The MADs are about the same. Okay, so I'm going to write candidate A. I'm just going to put my explanation up here where I have a little more space. Candidate A has a higher mean. But the MAD is about the same. Okay. Now let's take a look at B. It says express the difference in the measures of center as a multiple of the measure of variation. Difference means you subtract. Multiple means we are dividing. So here's what we are doing. We're subtracting our measures of center. So we're going to do 84 minus 58. As a multiple of, that means we're going to divide our measure of variation, which we said was about 16. If we had things that weren't about the same, let's say I had 10 and 16, then I could just divide with those numbers to get my new value. Okay, so let's see. If I did 84 minus 58, I would get 26. And then when I divide by 16, I get 1.625. This number here tells you about how much overlap there is between the data sets. So the 1.6 tells you there's some, but not a lot of overlap. So you can see that there's quite a bit of overlap in between the two data sets. All right, let's go ahead and take a look at our next problem. What if each data in the value in the dot plot for candidate A increases by 30 seconds? How does this affect the answers in example 1? Explain. You don't have to calculate it, but pause the video and write down how you think this would be impacted. All right, so let's check our answers. If everything was increased by 30 seconds, the mean would be higher because all the numbers would be bigger. But the MAD would be the same. The reason the MAD would be the same is the numbers aren't any more spread out than they were before because you added the same amount to all of them. Mean tells you the middle. MAD tells you how spread they are apart. All right, let's take a look at our next example. This time I have my data on a box and whisker plot, and again, I have two pieces of data that I need to compare. It says you want to compare the cost of speeding tickets in 2 states. The double box and whisker plot shows a random sample of 10 speeding tickets issued in 2 states. Compare the samples using measures of center and variation. Can you use this to make a valid comparison about speeding tickets in the 2 states and explain? So for state A, when we look at the middle for a box and whisker, we look at that line for the median and we imagine it folded in the middle. We look at, is the box about the same on both sides? On this one, yes, that box looks pretty symmetrical. And then we look at the whiskers to see if they're about the same. This one's really tiny, this one's really long, so it's going to be a skewed data set. If one is symmetrical and one is skewed, we still consider the whole thing to be skewed. So this is a skewed data set. So that means when we compare, we're going to be using median and IQR, which is good news for us because on a box and whisker, a median and IQR is going to be a lot less work than what we did on the last one. Okay, so we'll start with state A. Okay, median is the number in the middle. We don't have to do any calculating on a box and whisker. They'll tell you that number directly. For state A, it's 70. IQR, that's how big your box is. You're subtracting the numbers on the sides. So here, this would be 60, and this would be 80. We're subtracting our upper and lower quartiles, or our first and third quartiles. So for this one, I would do 80 minus 60, and I would get 20. All right, go ahead and pause the video and find the median IQR for state B. Okay, let's check our answers. So median, this median is 80. And then our IQR, how big is the box? Our interquartile range, we're doing 100 minus 70 to get 30. Okay, so now we need to compare them. So we found our measures of center and variation. One, compare them. Okay, well, state B has a higher median and IQR. Higher median and IQR. And then 2, can you use this to make a valid comparison? This part I'm just going to write here. No, it's only 10 speeding tickets. It's too small of a sample size. So you can compare it, but it's not going to give you very accurate information. The sample size is too small. Okay, let's take a look at part B. The double box and whisker plot shows the medians of 100 random samples of 10 speeding tickets for each state. Compare the variability of the sample medians to the variability of the sample costs in part A. Okay, so compare the variability. Variability here means the IQR. Okay, so for the IQR, for A, let's see, we've got 60 and 70. Maybe a little more than 70. It's a little hard to tell here. I'm going to call that 72. So state A, it's about 12. State B, let's see. Oh, maybe 76. And 88. It's hard to tell exactly. So it looks like they are about the same. Okay, and then compared to the IQRs up here. So it looks like the IQRs are much smaller than the IQRs up there. It means the numbers are closer together. There's less spread. Okay, so you make a conclusion about the cost of speeding tickets in the 2 states. So we're going to look at this. And it looks like the cost for state B is going to be on average higher than state A. They have a higher median, and the IQR is about the same. So let's see, I will write the average ticket costs more in state B. All right. What if a random sample of 8 speeding tickets issued in state C has a median of $120? Can you conclude that a speeding ticket in state C costs more than in states A and B? I'm going to put it back on the last slide so you can see the pictures again, and then you're going to pause the video and answer this question. So $120 is the median for state C. You can compare it to here. Pause the video, answer your question. Okay, can we conclude the ticket in state C costs more than A and B? Well, that is a lot higher than what we have, but this random sample here, only 8 tickets. Sample size is too small, so no. The sample size is too small. Does it seem like it would be more? Yeah, it does, but we don't know for sure. All right, and our last one for today, go ahead and pause the video and write what you think for this one. Okay, let's check our answer. So to compare two populations, if the data is symmetrical, we're going to use the mean and MAD. If the data is skewed, we use the median and the IQR.